From our last discussion, we did discuss about the net present value. And I remember we did some examples of this net present value. And today we are going to discuss about the internal rate of return. And there's a booklet I've sent in WhatsApp. I hope you have seen it. I was trying to summarize this content according to the syllabus. That is the core application of data analysis. So the only part that is not in that booklet is that part of loan amortization, which we did. The practical part of it. I've checked on the time value of money, which some practical examples we did actually see. We are going to evaluate under this option of project evaluation techniques. That is what we are discussing right now. And we did that there are several techniques of evaluating the project, whether the project is viable or not. We said we have a number of ways in which we can confirm or we can confirm that the project is viable or not. And the first one is the net present value, which we did in our last discussion. So here we said that when the net present value is positive, then the project is viable. When it is negative, the project should not be accepted, so it should be rejected. So today we are going to check yet another parameter that will help us to know whether the project is viable or not, that the use of internal rate of return. Internal rate of return. And when we talk of the internal rate of return, we are referring to what? Specifically, we say that the internal rate of return is used to calculate the internal profit for some investment. And in finance, that is actually itself is a built-in function in Excel that we use to calculate or to confirm or to tell whether the project is viable or not. So, and in that booklet, I have sent you about financial functions. You actually see the same that has been covered there. We are going to run some exercises in that small booklet. Then other more examples, you will get them from the book that I have sent you in that WhatsApp group. So one, we will say that when we talk of internal rate of return, then we say that the internal rate of return is the discount rate that makes the net present value equals to zero. So whenever you do an investment, that is you put your money on a saving account, for example, in the bank, and you are given an interest of a specific percentage, then you will find that your money probably is not growing as the same way you could have invested this money in an investment company. So why? Because the internal rate of return probably is equal to a discounted rate, which will do what? Which will always lead to a net present value of zero. So we are going to use an example that I have sent you in the last discussion. I would like you to, let me check that example that we sent in our last exercise. So just a minute. So there is that Excel worksheet I send you, or let me send it again. Probably you don't have it, but I want to send it again. If you have this example, please, you can have it. You can just open that example. And if you don't have it, then I'll have to send it. Someone says about the volume is low. I think you need to adjust the volume level of your machine. Just adjust the volume level of your machine because I think the sound is just fine. So then, as I look for that, I want to send that exercise to your machine so that you download the exercise and then we use it here to check about the internal rate of return. So today, we're going to extend a bit. We are going to extend a bit because of some few minutes that has been set with some technical issues. So you'll get the file there on that platform, that is the Zoom platform and the charts. You go through the Zoom platform and the charts, then you open that file. Is actually written NPV file, or maybe let me have, maybe I can delete it. Okay, it's just written NPV file, no problem. Then you click on sheet 3. Sheet 3, I've sent it there. I think that worksheet is still in the WhatsApp group. So you get it in your WhatsApp group. It is written NPV. So just download the worksheet and then open, move to the third worksheet, you'll get it there. And that is what we are going to use to discuss about this internal rate of return. So once you have that worksheet, you just worksheet, we have sheet 1, we did NPV, sheet 2, we did MPV, sheet 3, we also did MPV again. And they are like in that worksheet, in sheet 3, there is something I would like you to see there, that will given an investment of this amount and leading to a 0%. And here, the NPV is actually leading to what? 32.25 when the cash flow or the cash flow starts with 152. There's a very big difference between the two. So just click on sheet 4. Then in that worksheet 4, we are going to change the rate, the discounted rate, to 10% in both the projects. So type 10% in both projects. Then let's now go back to this, our argument here. So what is our argument? So here, simple internal rate of return example is where project A requires an initial investment of this amount. It's already provided somewhere. We expect the profit at the end, zero profit at the end of the first period. That is what we have seen in our example here, that we invested this amount. The first return profit of our project is 0. The second is 0. Then the third one is 152.09. That is at the end of the third period. So if you are to, the discount rate is equal to 10. So this is the rate of return of best alternative investment. For example, you can also put your money in a saving account at the interest of 10%. So the correct NPV formula, once inserted here, is supposed to evaluate the series of future cash flow and subtract for the initial investment, which we did in our last discussion that when you're inserting the net present value, then you select the cash flow as we have given here. Then again, we do what? We subtract from this B6, which has our initial investment. Remember, we put plus because the amount was given us as a negative value. So we do the same in the two exercises. Remember that our internal rate of return, our discount rate is 10%. So meaning that this one give us a net present value of 14. This one give us a net present value of 77. So with this now in mind, our internal rate of return, our net present value, explanation of this figure we have got here is that the net present value indicates that the project rate of return exceed the discount rate. And if the net present value is greater than the discount rate, then that project is viable. That is, you actually get returns. You automatically get more returns from that project, from that investment. That is, if where you have placed your money, the discount, the net present value or this net present value is positive, then automatically we say that the project is better than investing your money on a saving account. Now, we are going to use the internal rate of return again to confirm the same. So the internal rate of return of the same project, we are supposed to insert the function here. And how do you insert that function? For internal rate of return, it's very easy to compute that function. That is, you just click on that cell. I know that it's already computed. Just delete that answer. So how do you insert this internal rate of return? You'll start with an equal sign. And before we even write about this internal rate of return, I want to discuss about the parameters of the same. That the internal rate of return formula has certain parameters that we use. And when you insert this function in Excel, then it have to require you to set up the range. The range is a required parameter. A range of cells denote a series of cash flow for which we would calculate the internal rate of return. So that is the first parameter. The second parameter is guess, and this is an optional parameter, meaning that it is not must. You don't have to put it if it is not provided. And in case you can guess, because guess here means you guess for a number that is close to the results of the internal rate of return that you wish. If the number is mentioned, if not mentioned, then it is taken as 0.1, that is 10%. Those are the two main parameters that you need to set when inserting the formula internal rate of return. That is the value and the guess. So in this case, now we insert the function. We will start with an equal sign. We type internal rate of return. And this function returns the internal rate of return for a series of cash flow. You double click the function. And then you select the range of cells. So here you highlight that range that is starting from the initial investment, the first return, the second return, and the third return. That is the range which is must, it have to be set. Then the guess value, we said, is actually a value that we don't have to present here. So since you are not presenting the guess value, you just close the bracket and press enter key. So that is when inserting the internal rate of return, you start with an equal sign, then you type internal rate of return. Then you select the internal rate of return formula, you select the range of cells that has our cash flow, and you press enter. So it will indicate the internal rate of returns of a project, as you can see there. The internal rate of return of the two projects, this will give us 15. Then what does that one indicates? So let me change these figures. Here, I'll type 152. That is the first return, was 152.09. It returned the same amount, but it returns it earlier. And you'll notice that the internal rate of return here is 52, while this one here is 15. First, this one will help us to know that the second project is better than the first project. Number two, if you're using the internal rate of return, then you can conclude in this manner that the internal rate of return, when the internal rate of return is higher, that is higher than the discount rate, then automatically we say that the project is viable. The project is viable. When the internal rate of return is given as a percentage, when it is higher than the discount rate that was given when computing this, the investment, that is the rate of return you are given for an investment. You are told that to invest $100, after every 1 year, you'll get 10%. That is the return of your investment. And the first year, you did not get anything. You got 0. The second year, again, you got 0. The third year, you got this amount at this 10%. When you compute the internal rate of return and find that the internal rate of return is higher than this amount or this rate, then we say the project is actually worth. The project is worth. That way we are saying that the internal rate of return is one of the techniques of actually confirming whether the project is worth. Project evaluation. One of the project evaluation technique. So, and here the conclusion is the internal rate of return is the discount rate that makes the net present value equals to 0. So to clearly see this, now I want to replace the discount rate that was 10%. We replace it with 15% because the discount rate was 10%. If the discount rate or the discount rate 10%, if we replace this one with our internal rate of return, which is 15%, now what will be our net present value? It's supposed to be equal to 0. So we can practice that. That is, if you replace this one with 15%, then you find that our net present value equals to 0. In 2 examples, again, if you replace this one with 52%, then the net present value equals to 0. What does that one mean? This simply means that we cannot say that the investment is not bringing anything, but this investment is no difference with putting your money in a saving account. There is no difference because the net present value is not growing. That is, it remains the same. That whatever you invested, you got the same percentage of the investment that you are initially given. That means that project is not doing better, is not actually doing a little bit, is not actually doing better than maybe what a saving account could just do. So that is what you need. That is another way of arguing whether your project is worth. That if this rate of return is far much low, say like it is 10, it is 9%, then you'll find that your net present value will go higher. You go higher. So that means the lower the discount rate, then the higher the net present value, and the better the project. So that is something we have just confirmed, that we can use the internal rate of return. We can use the internal rate of return to do what? To confirm whether the project is viable or not. So that argument, I hope, is very clear. The explanation of that is already in the book that you have. That there are some people who are asking for the notes every now and then, every day. And I have already put those notes on the book, on the WhatsApp. So please, if you want the notes, just get them through the WhatsApp groups. The notes are there. Then again, as we proceed, we'll be putting those notes on the same WhatsApp. Remember, we still have more materials that we are going to share there. So you'll get those materials from there, including the workouts of the previous past papers that were done. That is, the solutions of those past papers will still be put there in the group. So that is, you expect to get them on the group. So for sending you the notes direct, remember that there is someone who is sending those notes. There is a person who is specifically doing that work. So he cannot go sending to every student. That way there is that group. So just join the group, you'll get all the notes there. So the explanation of this value that we got here indicates that the project generates a rate of return equals to the discount rate. In other words, both options, investing your money in a project or putting your money on high yield saving account at an interest rate of 15%, yield an equal return. So we have already checked that and we have seen it's true. So that is another way of actually doing what? Of getting or doing project evaluation. Remember that we're in this book checking about the project evaluation. In this book, I've sent this book just some few hours in your WhatsApp group, and the book we are discussing about project evaluation techniques. So far we did net present value. Right now we have just gone through the internal rate of return. We have just done those two. And we have seen that when you are running the internal rate of return, then you can also predict, you can also check the project. Now, if you want to check, like here we have an example. Another good example here, that there is a project here that is supposed to return some amount. an investment that was made. And this investment, you have this. Now this one, I think you'll have to type. I don't think whether I have that exercise with me here, but you'll have to type that. Just a minute, let me look for it. Is under this, under what? NPV, internal rate of return. So that example, just type this. If you can, just type very fast. I really don't have this in my. Or let me just allow me to. I think you have this exercise. Where do you have it? I think you have it. Let me check. Yes, you have this. You have this. I sent this. I already sent this, and we actually did this. We actually did this on our last discussion. We said that when you insert the internal rate of return, in this case, you can evaluate that our project after the third year, that is the second, the first, the second, and the third year, our internal rate of return is negative. That indicating that the project rate of return, that is our project has not yet returned the amount we borrowed. That is the amount we invested. So if you compute the internal rate of return after the 5th year, then our project has already returned, because it will give us a positive value, which we already got there. So we did this in our last discussion. I think we remember that. Is then there is now the last thing that you're going to check here, that the internal rate of return being an Excel function, it will only return if you are given, it will always only give you the value if you are given values that are a combination of positive and negative numbers. So meaning that if you are given only the positive numbers, the internal rate of return won't work. It will not work. So we can do internal rate of return in Excel in 2 ways: the worksheet function, which we have inserted, or there is another way we call the VBA. Is not actually in the advanced Excel about the VBA. VBA is a macro that we use the Visual Basic Language. There you have to code. And that one you do not actually do here, because you don't have to code here. Normally for the IT people, people who do that coding. And they can also generate and create a worksheet that will generate internal rate of return through coding. But the only thing that you realize here is that if you've invested this amount, you can type these two numbers, these numbers here, in that worksheet, in the second worksheet of this worksheet I send you. Just open that worksheet. It was written example. Then go to sheet 2. There in sheet 2, you can have this simple piece of data. You can have this small piece of data here. Let me share it side by side. Then I will type these numbers, starting with minus 3,000, followed by 2,000. So the first one indicates the amount invested. The second one is return for the first period and return for the second period. And you are told now get the internal rate of return for this. How do you get this? You say is equal to internal rate of return. Then you select the values from here to here to give you 67%. So our internal rate of return is 67%. Remember here, we are not given the discount for this, the rate, because when you're computing the internal rate of return, the discount rate is not even used anywhere. You just use a series of your payment. So, and you'll find that you just use the cash flow, you'll find that the amount is 67%. What will happen if the internal rate of, or when you're computing this, you can see that in this internal rate of return, where we have this, denotes the capital invested, then the following number, 2,000, 5,000, the income, then it will give you as this as the result. But if you check the next part, if the amount invested was put as a positive number, then you'll notice something here. It will give you something like that. Now, that error. Why? Because when you are running for this internal rate of return, then you cannot have all values being negative or all values being positive. There is no way you can rectify this error. This is one of the errors you cannot rectify. So, meaning, if you want to rectify this error, you have to go back and look where you have made the mistake, because there is no way you can insert that error. You can rectify that error. So, the internal rate of return in this calculation has given this. It is displayed as a result because there is no single negative value present in the set of values. So, there is no value indicating the payment, but all are income. Hence, no internal rate of return that you expect here. So that is the same thing when you put all values negative. That is, you invested 3,000, but the first one gave us a loss of minus 2,000, and the second one gave us a loss again of minus 5,000. Then it will give you a NAM here, requiring that when you're running this, at least some figures must be positive or others are negative. So the internal rate of return in this example generate the same NAM, that is the error. So you must at least have some negative values and some positive values. In this example, we did this discussion. We said that for internal rate of return in this example, the amount invested was this. Then the following values as per year, the income earned 1 at this, that is the first year, the second year, the third, fifth year. Yes, so you calculate the income generated at the end of the third year, then applies that the internal rate of return formula, say ranging from B2 to B4, result to a minus 19%, as the payment amount in the initial year is more than the previous year income. So to calculate the internal rate of return on the fifth year, then it gives us 22%. The results positive, as the income generated in the following years is more than the payment amount invested on the initial year. That's why it has given us a positive value. So that is what you need to know about these two functions, the internal rate of return and the net present value. So remember that there are other options you can use again to tell whether the project is worth investing in, like the payback period is still another way of actually confirming. I've not added that one in the book, but I'll add this one there in the book again. To that book, I'll have an updated copy of it that shows other ways of actually checking whether the project is worth or not. So, summary we have seen here about these arrays. We have the internal rate of return. So it's just what we have gone through, the summaries of each one of these functions. But the value array must contain a minimum of one positive or negative number. The value should be in a sequential order. Internal rate of return uses order of values to interpret the order of cash flow. So please take care of entering the payment and income value in a sequence as they happen or you desire to make it happen. Then Microsoft Excel uses an interactive technique to calculate these, starting with a guess internal rate of return cycle through the calculation until you get the accuracy of this. So you give an accuracy of a specific amount. So then if IRR cannot find the result that works after 20 tries, you have tried several times, then this one will always appear. So the internal rate of return Excel function, when it returns this, then or result not around what you expect it to be, then try with a different value. Just change the values. Then in most cases, you need to not provide the guess number, the guess value for internal rate of return calculation in Excel. However, if the guessing parameter is skipped, the software always take 10% of it. Then IRR closely related to net present value function. The rate of return calculated by IRR in Excel is the interest rate corresponding to a zero net present value. We have seen that so far. So that is the first part that we actually need to go through about the internal rate of return. So I believe that one is fine, and hope everyone is now in the right, that is, we are able to understand that. So other ways of actually confirming whether our internal rate, our project is worth or not, we have other methods you can use. Like we said, we have methods like use of the payback period, which we are going to see over here. Though I don't have those exercise typed, and I don't want us to waste a lot of time typing it. So we can still do check on this in our next session. Now with the data already typed, but just briefly, we can check that we have other ways of actually confirming that the project is worth or not. We have done the first, the net present value, the internal rate of return. Other techniques include the payback period. When you talk of the payback period, then you're referring to the number of years it takes to recover the investment initial cost. And the shorter the payback period, the better it is. So when you're running the payback period, then something like this will happen, that we are given two projects. We are given two projects. Here we are given project A and project B. This data I'm saying I don't have this data. So meaning you have to, when I send this copy, then it's already there in the copy. You just download, type the data, then you can compute that function. You can just compute. So let's see. So here, the payback period for project A, we are given this project here. Could be, can just try this. Can do it in the third worksheet. What are we having here? What we are having is something of the sort. Particulars. Then you can have one project at a time. You can even have all of them here at the same time. So here you can type in the data. So you just type the data. set the project. We have the project A. We have project B. We have those two projects. And the years you are given here, first year 1. Just type this data as I type it. When you type year 1, you can generate the rest down here by just scrolling down. Get year 1 up to year 4. So as we take the data, so I have been handling some questions from some of our colleagues who are saying that maybe they are a bit floating when you do these exercises. They really don't get the concept. But maybe to be a bit sincere, is that this paper is a purely practical paper. And if you are not doing it in computer as we do, then I think you are not doing it right. Because when you started learning, I said that you'll be logging in with your phone. And then as you do here, you do it in your machine. That is what we said as we started these units. So if you are just looking and just smiling on the screen as we do here, then maybe because you have been using Excel and some of the things maybe you are doing here, they may look so easy. But if you don't practice it, then it will be difficult for you. It will be a bit difficult when it comes to real life. That is, if you are doing it the first time in the examination paper, we have been learning and you have never typed anything. You'll go and do it the first time in the examination paper. I don't think you are sincere to yourself. That is not being sincere to yourself, because it cannot work that way. So as you practice here, you'll be realizing some things that probably there's something you have been doing there with a machine, maybe when typing the data, when inserting the formulas, and maybe you have been using a very long method format. Yeah, but as you do it here, you realize there are shortcuts for the same. So please be typing something. Typing something to help you to. So we are given year 1, the initial. Okay, this was the initial investment. We had the initial investment was here. So we'll put our initial investment. Copy these. Okay, I get it. This is not year 1. Year 1 start from here. This was the initial investment. So the initial investment is the amount we invested in our project. We have set our figures into the currency, and we have used the dollars, just use dollars. And in this investment, we have seen that the two projects, the first project we invested is money. Its payback is constant. That is, it pays this amount, a constant amount. It is paying a constant amount of $100. Then you are asked to give the payback period. The payback period. So, which is the payback? What is the payback period? Then we are here. We want to type pay back type the payback period. So how do you get the payback period here? Just do this one by a simple formula that if the project is paying $100, then to get the payback period, you use a simple Excel formula. That is, we will take the amount invested divided by the payback amount, that is paying every time. So meaning that this payback period will be 10 years. That means project A will pay back this amount invested in 10 years. So what about project B? Project B is paying at different rates. Sometimes it pays less, it pays more, pays less. So what you need to know is how much has the project paid. So we will just sum. You can insert the function sum, and we sum this amount from here to here. And once you press sum, you realize that the amount that we typed, or the amount we have got here, let's do it here. Let's just do it here. Let's copy this formula and put it there. So the project has already returned. It has already returned our amount so far. So meaning that it will take only this number of years. That is, if you count here, you see that count those cells with just say count. We are counting from here to here. Then it has taken us only 4 years to pay back this amount. So these are the payback periods of the two projects. So then we can simply say that the project A is worth investing in. The reason being that it pays back our project within a shorter time. Project B pays shorter time than project A. So that means we said the shorter the payback, then the better the project. So, and that is a conclusion that we did made there when using that payback period. So here, project A depicts the constant cash. Hence, it pays back, in this case, is calculated as the initial investment divided by the net cash flow. So therefore, the project A, to meet the initial investment, will take approximately 10 years. For project B, we have said that in this project, we'll add all the inflows. That is, the investment was 1,000 and is covering 4 years to pay. On the other hand, this project B has an even cash flow. In this case, if you add up the yearly inflow, then you can easily identify in which year the investment return would be close. So the investment requires the project to meet 4 years. By the 4th year, it has already paid its investment, the amount invested. So comparing the two projects, in project A takes more time to generate any benefit for the entire business. And therefore, project B should be selected over project A. So that is another way of evaluating project evaluation using the payback period. We said the longer the payback, the shorter the payback, then the better the investment, So a good investment is the one that takes a shorter time to pay back the amount invested. So we said when calculating this, what did we do? We just say is equal to the amount, the initial investment, divided by that constant payment. You can take either. And when you do this, it will give you the number of years it will take to complete or to pay back this project. So that is another way of actually evaluating whether the project is worth or not. So the other way of doing the same is using that discounted payback period method. The discounted, I know you did the discounted payback period with so many formulas in Excel. Indeed, you did those formulas and you computed the same. Here in Excel, you can achieve the same with the easiest way possible. That is, consider the project where the initial investment is the same, using that discounted payback period method. We can check if the project selection is worthwhile or not. So, and what happens is that it is an extended form of payback period where it considered the time value of money factor. Hence, using the discounted cash flow to arrive at the number of years required to meet the initial investment, and we will find a project life. The project life is expected to take 6 years. Expected to take 6 years. This is our project here. It was expected to take 6 years. So we can have these values here. Let's have the values. I don't have these worksheets, so the only way we can do is to type them. So, and I want us to have this same worksheet. Here we have years. We have number of years. That is here. We have the discounted cash flow. The discounted cash flow. So then we have the initial. The initial costs through remaining. Initial cost through remaining cost. Is initial cost stroke the remaining. So that is our data. So we want to form this data. Now here, this is supposed to be here. So I had another issue. Maybe it's good to confirm as we proceed. We are switching between one worksheet and the other. One worksheet to the other. And somebody was a bit confused how we are switching from one worksheet to another. And because of that switching, he just floated around. I don't know whether switching from one worksheet to the other is actually part of computer basics. And for those people who attended the first lesson, we started from there. We started from the basics computer skills, especially Excel skills, the basic Excel skills, using simple formulas in Excel. That is something you should, you actually need to practice yourself, the Excel functions. So, how do you gain these skills? You can only gain them by practicing, using some exercises from Excel. I think there are some exercises we have been doing there. You can use that that small worksheet to practice. This was meant, that was meant, it's only meant to make you perfect in Excel. That is, use Excel, produce a network, and do alignment properly, text alignment, applying your borders properly, inserting the right formula. So that was the basic part of Excel. We did this one because we believe that some people maybe have challenges with Excel, so we could not just assume that everyone knows Excel. So here we're supposed to insert a formula. Our worksheet should be up there because the other value is supposed to be generated. So our project life is expected to return the initial cost at year 6. That is when you expect that this project should return. And that is year 6. So here you put a formula that you allow us to get the remaining balance, that in year 0, the discounted cash flow did return 0 because this is the time we invested our money. That was the first investment. So during that time of investment, that is what we expected, that this is what we put, that is what the initial investment. But now the first year, the discounted cash flow was 1,000. That is our project, our investment brought a profit of 1,000. So what will be the remaining balance? Then you say equals to the initial cost minus the discounted cash flow, This one will give us the remaining balance of the next year. And with this one, you can copy down our formula until it will reach either 0 or it can go to negative. When it goes to negative, it means by the time we are reaching here, our project have already paid over and even actually exceeded. That is, our project has already paid over. This is the amount it is paying. We invested 10,000. And at this time, at the fifth year, the project has already paid 9,200. 9,200. That says it only requires 800 to pay off the project. That is, you can go computing the total. That the total of this, how do you get the total? So if you are to compute the total, it will actually help you to know when the project will pay back. In which year will this project pay back? Then we can say that here, the total of this, you just sum these two. You can add the two values. That this was the amount invested. It should always be 10,000. If you copy down these, then you will find that here, the total is that. The total here is this. So the total here is, okay, is that one really fine? No. I don't think it is fine. Just a minute. So, okay, I've got this. I've got this. That is, here the formula will be equal to a constant value which will be this, made absolute. Then you go subtract this. You go subtracting this. That value will keep on changing. It will keep on changing. And the formula should be where? The formula should be here. And it will keep on something I'm looking for. Okay, just delete that. So by the look of these things here, you'll find as you add this, the total of this is supposed to use the weighted average or the weighted total. That way is bringing that challenge. The weighted total simply say that to get the value here, you say is equal to this plus this. To go weighting. That is here. Imebaki 1,000. Here imebaki 2,500. Here imebaki, and you proceed. Okay, just a minute. Okay. So there's a function that you're going to learn later called the moving average that can help us to actually get that. So now using this method, we have already seen that as you add the total of this, whatever it has paid back up to the 5th year, it has already paid how much? If you are to insert the sum here, then say the sum up to the 5th year is this amount. This amount here up to here, or you can even start from here, that it has already paid 9,200. So it is only remaining with what? With 8,000 to pay back. So this, the last value, it should be not available. Should be not available. That the value should be not there because it's negative. So simply means our project pays earlier than the expected life of the project. It is paid earlier than the expected life of the project. That is, the using discounted the cash flows that the project paid. By this time, the project has already paid. It only remaining this amount. So meaning that if you add this further, then means the project has already paid and exceeded. So that is another way of confirming whether it is worth investing to a project or not. That is, here we have that there are certain cash flow over the years under the same project using the time value of money. We calculate the discounted cash flow at a predetermined discount rate. And in column C, we have seen that. And above, the discounted cash flow, and the column D identifies the initial cash flow that covered each year by the expected discounted cash flow. The payback period would lie somewhere between 5 and 6. That is the 5th and the 6th year. Now, since the project life is seen to be 6 years, then the project gives return in a lesser period. So we can actually say that this project has a better NPV. Therefore, it would be a good decision to pick this project that can add value to the business. That is another way of confirming whether the project is worth investing in. Using what? Using the discounted cash flow, the discounted payback period. So after that, we have seen the last way of confirming is profitability index. That is the profitability index, that using the budget method of profitability index to select between two projects, which are option tentative with the given business. Then this is project A, this project B. You have the initial amount invested, the same amount, and these are the return for every project. The profitability index for project A is computed using a formula. And you know the formula of this, I think there is somewhere you did profitability index. So you need to use the formula that you used in class. Here I have a different, okay, it's not different, it's the same formula in a different way. That profitability index is equal to the PV of future cash flow divided by cash outflow. The present value of the future cash flow is given down here. That is the present value of the future cash flow. First, you compute the present value of the future cash flow. You get it there. Then from there, you calculate this. The profitability index for the project A is given as this amount. And profitability index of project B using the same formula is given as 0.09. The first one was 1, the second one was 0.09. So hence, to conclude this, we say profitability index our profitability index also involve converting the regular estimated future cash flow using a discount rate, which is mostly the weighted average cost of capital of the business. So the sum of this present value of the future cash flow is compared with the initial investment, and thus the profitability index is obtained. So if profitability index is greater than 1, it is acceptable, which would mean that the inflow are more favorable than the outflow. In this case, project A has an index of 1, that is 1.6, compared to project B, which has an index of 0.90, and which is clearly that project A is better option than project B. So that is another alternative of actually generating or confirming whether the project is worth or not. So there are several ways of actually confirming that. And we have seen using what? Using profitability index. So that will mark the end of that part. That is that part we have seen about project evaluation techniques. So I've sent this, I'll send more information on that booklet showing the same. That is, I'll add the payback period, the profitability index, and the discount payback period. Those are methods you can use, or these are the project evaluation technique methods or techniques. So that is our second discussion. So in our next class, we will discuss about the sensitivity analysis. Sensitivity analysis. This is something you did actually. Sensitivity analysis in Excel. That will be our next discussion about sensitivity analysis. Just to give or to bring a more insight on this, I will just use a simple example just to have an information about the sensitivity analysis and how it works. Remember, we said that all these functions that we are discussing here are under something we call the scenario analysis. If you check there under the scenario analysis, you will find that scenario analysis is under the what if analysis in Excel tools that present the scenario manager, which we have discussed, the scenario manager. The other one is the goal seek, which give us the break-even analysis. And the last one is the use of data tables. So what we are discussing now here, what we are referring to as sensitivity analysis, is the use of data tables, the use of data tables. So it is something that maybe you remember very well, that sensitivity analysis is actually a way of risk management. And we're going to see that sometimes when you're working or evaluating the project, then you can use the data tables to evaluate the best way in checking over this. That is, which project is risky involving in, or project that is better, which option is actually better choosing, why not choose this and choose the other. So that analysis in Excel will help us to study uncertainty in the model output with the changes of the input variables. So it primarily does stress testing of the model assumption and leads to a value added insight. That is something you can use to evaluate and to make decision upon. So sensitivity analysis in Excel is especially useful in finance for modeling share, price, and valuation. Sensitivity to assumption like growth rate or cost of capital. So we are going to see this now. Using the data tables is actually the best way of doing this. That is working with data tables and working with the data tables. And we have two types of data tables, which you come to discuss later. That is one variable, and two variable data tables. So that is our next discussion. You need again to go and check about sensitivity analysis, which you did there. But here we are going to use the power of Excel to do the same, to do that sensitivity analysis. So with that, we are going to end our lesson there. Again, you can, I'll update that book. You get an updated version of the book. You can download that book and you can use it again to check more information. So remember that from next week, we will not have the link will be sent, but I think there is information you have already gotten from SAP. I think I laid that information here. Yes, I laid that information that we are using a free trial classes packages, but now we will not have, this has already expired. The package has expired. So from maybe next week now, you'll have to use that platform where you have to join, but you have to be allowed in. That is, to be allowed in is only those will be allowed in. This is an activation that we make. So that is the Zoom we have been using. We are normally given some period of time where we can invite as many contacts as possible. But once it reach a time when now we have to pay the version, that will now allow us to scale down this number of users. So this could be our last class that will be streamed just live for free. The next class, maybe you'll have to join. You have to make some arrangement with the office. Then the link will not be sent in the group. The link will not be sent in the group. The link must be sent maybe somewhere. The link will be sent somewhere that will be given. You'll be directed where to get the link. So I think today we are going to stop there. Our next class, just like usual, you have our next class next week on Thursday. So when we come to discuss about sensitivity analysis. So up to that time, wish you all the best for the weekend. Have a good weekend. And please do practice. If you have not been practicing Excel specifically, this test, we are not doing it for just to harass people. We want want you to get used to use working with Excel, producing neat work, producing something that at least you can upload in the examination portal. You want to improve the speed, but how do you improve the speed if you're not practicing it? You have to practice. So please do practice. See you next time.